Hello guys, today I'll be explaining my solutions to Leetcode weekly contest 304. And the first problem was make array 0 by subtracting equal amounts. So in this problem we are given an array and there are some integers, and each time we had to subtract the smallest non-zero number from each of the other elements, each of the other non-zero elements. So in the example 15035, first we are subtracting 1. It is the smallest non-zero element present in the array. The array becomes 04024. We are subtracting 2 now. It becomes 02002 and then a 0, all zeros. So if you do some math, and then you will figure out that the answer was just the number of all unique non-zero elements present in the array. So for that I just used a set, and if num is not 0, then I am just inserting it into the set and returning s.size. And for explaining that logic, we can do one thing. So first we should sort it. I'm doing this just to explain. There is actually no need to sort, and we can just use a set. But if you sort it, then you can in one iteration you can find out the number of all unique non-zero elements in the array. So here you can see that in one operation you are just making all the elements equal to the smallest element of the array equal to 0. Like when you are making the first operation, then 1 is the smallest element, so now only 1 will become 0. If there was one other one, then that would also become 0 in this operation. So you can see that in one operation you will remove, or you can make 0 all the elements which are equal to the smallest elements. So this way, like in one operation, you can make only those elements 0, and all the other elements will require separate moves. So this way it will also become 2 and these will become 4s. Now when you remove this 2 or subtract 2 from all, now you are left with 2, and if you just subtract 2 from all the elements, then you will get 0. So this way the answer was just the number of all unique non-zero elements. Okay, moving on to problem number 2, maximum number of groups entering a competition. So in this problem we are given some grades, and we need to divide these grades or these numbers into a group of numbers, and there were some conditions for dividing the numbers, and after that we just need to return the number of groups that we made. So if I just quickly show you the conditions. So yeah, these were the conditions. The sum of the grades of students in the ith group is less than the sum of the grades of students in the I plus 1th group for all groups except the last group. This small thing confused me initially, but after I spent some time and I understood what the problem set I was trying to say. Then the total number of students in the ith group is less than the total number of students in the I plus 1th group. So yeah, if we just for explaining, let me just sort all the grades. 4 is not there, 5 is there, 6, 7, 10 and 12. So here, first of all, the count of grades in one group should be lesser than the count of groups in the second group. or in the next group, and also the sum of grades should also be strictly lower than the sum of grades in the next group. So like the first group would be like 3, then the next group can be 5, 6, the next group can be 7, 10 and 12. This way, if we just sort all the numbers, then we are guaranteeing that the first condition will always be satisfied. Like if you take I plus 1 numbers for the I plus 1th group, like 3 numbers for the third group, and they are in the sorted order, like you are taking numbers from a sorted list in the right order, then the sum will always be greater than the previous 2 elements. So this way the first condition is satisfied. Now for the second condition, we cannot like think of some different or difficult kind of thing. We just need count greater than the last count. So yeah, if the last count is I, then the next count should be I plus 1. So this way in the solution as well, I just sorted all the grades, then I initialized answer to 1, then count to 0, and this count will keep the count of the numbers in the current group. So the target size of the current group is currently 1, which is denoted by the answer. So here I am doing count plus plus, denoting that the current grade has been added to the current group. Then if count becomes equals to like target size, then I am doing answer plus plus, denoting that the next target group size would be answer plus plus. And yeah, the next group is currently empty now. At the end I am just returning answer minus 1 because answer was denoting the target size of the next group, which is currently not made. So yeah, answer minus 1 would be returned from here. So this problem was, I think it was a bit unclear, like I solved in like 1 or 2 minutes, but I spent 2 more minutes just to see that if I am not missing anything. Like it was, I think, a bit easy, like they have mentioned it in the medium part, but I think it was an easy problem if only this thing was required to do. So yeah, this was problem number 2. Let's jump to problem 3. Find closest node to given 2 nodes. This problem, like you can understand it easily, but the solution is also easy. So let me explain the problem first. So you are given a graph and you are given 2 nodes, and you need to find the node. Okay, so let me open up the problem statement because it was a bit, what to say, return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. So yeah, this thing was a bit hard to understand. Like we need to minimize the maximum distance from node 1 to that node and from node 2 to that node. Okay, so let's say in this case, in the first example, 0 and 1 are the node 1 and node 2, and if we consider this 3 here, then the distance to this 3 from 0 is 2 and from 1 is also 2. Okay, so let me write it somewhere. So for node 3, distance 1, that means distance from node 0 to node 3 is 2, and similarly distance 2 is also 2, and we need to minimize this maximum of distance 1 and distance 2. So one way to do this is to find all the values of maximums of this 1 and this 2, and then just then just find the minimum of them. So these dis1s and dis2s are just the distances from node 1 to all nodes and node 2 to all nodes. Like this one is, let's say, an array of distances of node 1 to all nodes, not of, from node 1 to all nodes, and similarly distance 2 is also array of distances from node 2 to all nodes. And then like for each node in 1 to n, do minimum of distance 1 or distance 1 of I. Let's say the node is denoted by I, and distance 2 of I. So like the maximum of these two things should be minimized. So let's say there is initially an answer which is initialized to answer max, to int max, then we just need to do answer equals to this. And so there's some, so like we don't need to return the distance but the node. So like the value of I we need to return. So if this maximum thing is less than maximum of this one of answer and this 2 of answer, then what I will do is just set answer equals to 1, and this way just return answer. And now how to get this array like this one and this 2? For that you can just do BFS from node 0 and node 1 and fill the distance array. Like you are starting the traversal from 0, then you will visit all the children of node 0, which is 2 in this case only, and set the distance of 2 to 1, and then apply same BFS to node 2 and visit all the children that are not currently visited. Like in this case 3 is the node, and fill the distance of 3 to 2. This way you can create the distance array. In the contest I did in a bit complicated way, that's why I explained the easier approach here. So here what I was doing is that I first created the answer the adjacency vector, then there are 2 visited arrays, all are initialized to false, and also the distance vectors. -1 denotes that the node is not reachable from node 1 or node 2. Then initializing answer to, like if both nodes are equal, then I am initializing answer to node 1, or otherwise int max, denoting that no node is currently my answer. Then there are 2 queues for doing BFS, pushing node 1 into Q1, node 2 into Q2, and also marking both as true, like both are visited now. And distance is initially 0, but I think this was not needed. So initially I understood the problem incorrectly. I thought they were asking me to minimize the sum of distances, but they were asking to minimize the maximum of both distances. Then this one, node 1 0, like when you are starting from node 1, then the distance from node 1 to node 1 is 0. Similarly in the node 2 case as well, if any one of them is empty, then I will do the BFS first I am doing BFS for node 1, then I am doing it for node 2. And so yeah, the main thing that I notice is that either either I will visit node 2 from both nodes at the same time, or it can happen that I am visiting I got to node 1 from node I got to node 2 from node 1 earlier than getting to node 2 from node 0. So like first I visited node 2 from node 1, and after let's say 2 or 3 moves I am visiting node 2 from node 0. So in both ways, in both things, I will set the distances to both nodes, and yeah, and then I'm checking it here. If the distance to that node is not -1 from node 1 and node 2, that means that the child node is reachable from both nodes, node 1 and node 2. Then I am finding out the maximum of distances. The distances of the child node, the candidate answer and the current answer, and then yeah, if that distance is lesser than the answer distance, then I will update my answer to child. Otherwise, if it is equal, like the distances of the candidate answer and the current answer are equal, then I will set answer to minimum of answer comma child, because it was also asked in the question that if there are multiple answers, return the node with the smallest index, and if no possible answer exists, then return -1. So that case is being handled here. And if like currently I am not having any answer, then I will set the current node to my answer, and then at the end I am just checking if the answer is int max, which means that there is no common node which can be reached from both node 1 and node 2, then I am just returning -1, otherwise answer. So this problem is a good problem. It is, the medium thing justifies it. Yeah, moving on to problem number 4, longest cycle in a graph. So in this problem also we are given some directed graph, and we need to find the length of the longest cycle present in the directed graph. So this problem is like easier to understand, but I don't know if it is easier to solve as well. Yeah, there are close to 2500 summations, so I guess it is also an easy problem. So for solving this problem I used Kosa-Raju algorithm. So first I did the DFS in the graph that was given to us in the question, in the problem, and then I did DFS traversal in the reverse graph. So here you can see that this is like, here I am creating that adjacency list of edges, and then here I am doing the DFS, and with it I am keeping a stack, and inside this stack I am pushing the nodes after like traversing whole its subtree or subgraph. And then once I have done this, then I am reversing that adjacency list and creating a reverse graph, and then doing DFS on that reverse graph, but in the order of the vertices that were pushed into the stack using the first DFS. So yeah, this, like, all that I have explained is just a Kosa-Raju algorithm, so I think you should check out what Kosa-Raju algorithm is, and you should search about it on the internet. It is a bit hard to explain because, yeah, I don't know why, but it is hard to explain. So if I like dry run it in the graph, so that would be good. So there will be this stack, let's just call it st. So first I am visiting current equals 0, then from 0 I will go to 3, then the value of current will become 3, then the child of 3 is 2, so I am at 2 now, then from 2 I will go to 4. Right now from 4 I will not go to 3 because that would be marked as visited here. So at this point I have like completed one traversal, and I will push 4 into the stack, then I will push 2 into the stack, then I'll push 3 into the stack because all the children of 3 are visited now, then I will push 0 into the stack. Now 1 is not visited, so I will do DFS from 1, and from 1 I will not go to 3 because 3 has been marked visited already, so now I will push 1. Yeah. Then I will do the DFS traversal in the reverse graph. So I haven't drawn that graph here, sorry for that, or maybe okay, so we can do DFS here itself. So firstly I will like do DFS for 1, and I should have drawn the reverse graph. So we just need the reverse edges, right? Okay. From 3 to 1, from 3 to 0, from 3 to 4, and from 2 to 3, also from 4 to 2, and this is a directed graph. Yeah, I think it is good now. No. So firstly I will visit 1 because it is the topmost element present in the stack. So from 1, so there are no children of 1, so I will just do return from here, and yeah, so we can call it val. So 1 is returning val equals 0. So for val you can refer to this DFS1 function. Here first I am marking the current node as visited, and also having a count. Count will denote the size of the cycle, like the length of the whole cycle, and at the end I will add 1 to it. Here you can see for the current node, the node from which the cycle was started, right? So all in all, this DFS function will give me the size of the cycle minus 1. So for 1 the size will be 0, and then I will visit node 0. So I can also like create a copy of that stack and then delete the nodes one by one. So when I am visiting 0, again the val will become 0 because there are no children of 0. Then the value of current will become 3. So yeah, 3 has one child, which is 4. So like the val will become 1, then current will become 4 now, and val will become 1 in this case, or val will not, like currently val is not defined. Val will be defined once the cycle has been completed. Now current becomes 2, then I will try to visit all the children of 2, which is 3 in this case, and 3 has already been marked as visited, so I'll return 1 from it, or I will just return 0 from it, I think. Yeah, because I am not even visiting that node. If I had visited that node, then yeah, it would have been 1. So here it will not even come inside this if condition, and it will just return count as 0. So once it returns count as 0 in the if condition of when the current node was 4, so it will come inside this if condition, and this dfs1 call will return 0. I'll add 1 to it, and count will become 1 now. So it will return 1, and similarly it will return 2, and at the end I will do answer equals to maximum of answer comma size plus 1, which is the length of the cycle, with the value which is returned by the dfs1 function for current equals to 3. So yeah, 3 plus 2 plus 1 3. Yeah, the value returned was 2, and I will add 1 to it, so the length of the cycle will become 3. And also, like, the answer is 3 in this case, if you were wondering. Yeah. So this way 3 will be popped out. Now 2 has already been marked as visited, so I will just pop out 2, and then I will just pop out 4. So yeah, this was it for this round, I guess. The last problem was a cute problem, I would say, but yeah, the problems were all in all good. And I can also discuss the daily Leetcode problem. It was just a standard segment tree problem, like the range sum with modifications. So for that I have implemented the range query, or the segment tree, iterative segment tree I have implemented, not the recursive one. I prefer iterative way more. This is the main array which is initialized in the initializer, and here firstly I am setting the next n elements. So the size of that array is 2 into n, and the last n elements will contain the element same as the given array. So okay, let me explain this as well. Yeah, the given values are 1, 3 and 5, and the array initially is of size 2 into n. Let's just say underscore underscore underscores. And then the last n elements are same as the given array, and the first 3 elements will be, so like this is index 2, and it will contain the value, it will be containing the value which is the sum of the elements which are present at 2 into 2 index plus 2 into 2 plus 1 index. So 2 into 2 means 4, and at index 4 3 is present, and at index 5 is present. So this will contain 8, and this index will contain the sum of values at index 2 and 3, so it will be having 9, and this position will remain vacant. And same thing I have done here. And then in the update function, I am first setting the value in the second part of the array, which is being done here, arri plus equals n equals to val. I will share the resource, like from where I have learned the iterative segment tree. I can share it right now as well. Iterative segment tree, yeah, efficient and easy segment trees. So yeah, this was the block that I referred to. This is the query function, this is the modify function, this is the build function. So yeah, you can refer to this blog. And yeah, the problem had really nothing else to explain. Like there were just some function calls were made, and yeah, that was it. So yeah, today's contest was good. It, like, I participated after quite some time in a Leetcode contest. So my rank was around 779, which is good enough, I think. We'll try to do better in the next round. This is it for now. Bye.